Dear students, greetings. In this lecture video, we are going to discuss about periodic analog signal in Unit 1. In self-learning topic 5, in Unit 1, we are going to discuss about periodic analog signals. So, end of this lecture, what is the outcome of this lecture? After listening to this video lecture, as a student, you will be able to sketch periodic and non-periodic analog signals and able to calculate frequency, phase, and bandwidth of given scenario. Okay. What is periodic analog signals? Periodic analog signals can be classified as simple or composite. First, what is periodic analog signals? Analog signals is a continuous signal. Periodic means we can able to repeat the same signal up to reaching the destination. Okay. So how we can say that? For example, the repeater, the form of the sine waves should be the same up to last. Okay, it will be repeated. Okay, so this is we are saying starting point, this ending point of this particular wave. So this will be repeated till end of the transmission. This is periodic analog signal. It may be classified into simple periodic analog signal, composite periodic analog signals. Okay. So what is simple periodic analog signal? So now I drawn here. No, this is a sine wave. Cannot be decomposed into simpler signals. Only the simple signal we are drawing using the sine wave, that is the periodic analog signal. There is no decomposed mechanism will be used. What is composite periodic analog signal? This signal may be composed of multiple sine waves. Okay, so how we can say this? If this is the timeline, so multiple waves are maybe composed in. This is the one wave. Okay, so another wave may be like this. So like this, that another wave, one more wave like this. So how the multiple sine waves are composed in single signal, that is considered the composite periodic analog signals. So this is a representation of periodic signal. So sine wave can be represented by the analog signals. Okay. So what are the terms we are used in this sine wave? Peak amplitude, frequency of the wave, and the phase of the wave. These three things we are going to discuss in this video. Okay, these three parameters fully described in a sine wave. What is the peak amplitude? So this perpendicular axis will be used for representing the sine wave. So this value is there, no? This value, this perpendicular here, that vertical axis. This vertical axis represent as the amplitude. Okay, so this vertical axis is represent the amplitude. So amplitude may be represented using volts normally. So in signals, amplitude may be represented as the volts. Okay. The next one, highest amplitude. So in this wave, this is the highest point. So this point may be represented as peak amplitude. Okay. You just remember that the peak amplitude means absolute value of its highest intensity. It is proportional to the energy it carries. Okay. So normally in electric signals, peak amplitude is normally measured in volts. So I already given here. So in this diagram, you can understand what is the highest amplitude of the particular sine wave. So here in this wave, this point, so absolute highest value of this wave is considered as the peak amplitude. Okay. So in this diagram, low peak amplitude. This is the high peak amplitude. This is the low peak amplitude. But this wave, what is the volt here? Maybe represented here. Okay. So this is the height of the amplitude. So here, this is the height of the amplitude. So it may be high voltage, it may be low voltage. Okay. So you can say that the peak amplitude in the sine wave. So what is the period? Period and frequency that we will discuss now. Okay. So period means in this diagram, what is the period? Period means how many full waveforms are reached per seconds, that we will see later. What is the wavelength? So now we can say what is the frequency. Frequency means how much waveforms are transmitted per second. So that we will discuss. And now period refers to the amount of time, it may be in seconds, a signal needs to complete one cycle. Okay. So you just remember that period means how much time in 1 second, how many cycles it is completed. Frequency refers to the number of periods in 1 second. Okay. Frequency means so 1 second, how many periods are completed. So example here. So here this point, this diagram, you can see this. Okay. The waveform is starting here. Okay. This waveform starting here will go for 90° and 180, 240, then 360. Okay. So once this waveform reaches the 360°, this is one period. Okay. So how many periods, total periods in 1 second? Okay, this is the timeline. In this timeline, it may be you consider up to this point is 1 second. Okay, so this 1 second, how many periods are completed? Up to this 1, up to this 2, up to this 3. So 3 periods in a 1 second. That is a frequency. Okay, 3 hertz. Normally the frequency will be represented in hertz. Okay. The period is formally expressed in seconds. Period means a timing. Don't forget it. Okay, frequency is represented in the hertz and period is represented in the time. That is seconds. Okay. So here you will see that I explained, how many periods are in 1 second. That is the frequency of one here. So you see that within 1 second, 12 cycles are there. Okay, so here in this diagram, this point up to this point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 periods are there in 1 second. That's why the frequency is 12 hertz. Okay. So same similarly, see here how many periods are there? 1, 2, 3, 4, 5, 6. So 6 periods are there. In 6 periods, within 1 second, 6 periods are there. The frequency is 6 hertz. Okay. But the particular one wave is completed the 360°. What is that? That is the 1/6. Total is 6 periods. This is the 1/6 seconds. Okay. So we must be know about what are the units we are used in both periods and frequency. So normally periods represented in the seconds and frequency represented in the hertz. Just see that seconds means 1 second, then milliseconds means we have to divide a second into 1000 parts. Okay, so that is considered as a millisecond. Second is one second. This second will be splitted into 1000 parts. That is milliseconds. It will be splitted into 10 lakhs. That is microseconds. So like that, 10 power minus 6, 10 power minus 9, 10 power minus 12. Accordingly, the milliseconds, microseconds, nanoseconds, microseconds. In frequency, how we can say that, we can multiply into thousands. Okay, so here kilohertz, already we know that 10 power 3 is kilo, 10 power 6 is mega, 10 power 9 is giga, 10 power 12 is tera, so like that. Okay, if it will be increasing order, that may be in kilo, mega, giga, tera, it will go. It will be reducing means milli, micro, nano, pico, will go like that. Okay, you just remember it. So here the power we use at the home, a frequency of 60 hertz. Okay, so find the period of this sine wave in milliseconds. So what is the question? So normally they are asking periods. Okay, so period means time. So period equal to inverse of frequency 1 by f. So period may be represented as the time. Okay, so t equal to 1 by f. So what is the frequency value? So frequency value is 60 hertz. So 1 by 60. What is the value? It will come normally. 1 by 60 means 0.16 something. Okay, so you see here 0.0166 seconds. So we can represent in the milliseconds. Milliseconds means what we have to do? Normally it is already in 0.000. So if we are multiplying with the 10 power 3, then we will get the milliseconds. Okay, so that means the seconds will be converted into milliseconds. Millisecond means 10 power minus 3 seconds. So if we want to convert into the milliseconds, means we have to multiply with 10 power 3. So finally we are getting 16.6 milliseconds. If we want to convert this value 16.6 into seconds, so milliseconds into seconds means what we have to do? Millisecond means 10 power minus 3. If we are multiplying with 10 power minus 3, that is the seconds. But we are converted seconds to milliseconds means we have to multiply with 10 power 3. Okay. So now another question. Express a period of 100 milliseconds in microseconds. Okay, how we can say that microseconds? Mu s means 10 power minus 6 seconds. Okay, that you have to remember. What is the time they are given? 100 milliseconds they are given. What is the 100 milliseconds? 100 into milliseconds means 1000 power minus 3 seconds. Okay, so what is the value of this? 100 into 10 power minus 3. So 10 power, here we can, 2 is there, 2 plus minus 3 means minus 1. Minus 1 seconds. Okay, so we can convert into microseconds. So what is the formula? Period is there given, we have to find the frequency. No, so here they are not asking frequency. Here we have to convert millisecond to microsecond. How we can convert it? You can see this. Then 10 power minus 1 seconds is there. Then here also microseconds is there. So now I have to convert into this. What is this 10 power minus 1 means? 1 seconds, 0.1 seconds. Okay, so that is 1 by 10. The value is 0.1 seconds. So 0.1 seconds wants to convert into microseconds. What is the value it will come? So we want to convert this value means multiply with plus 6. So automatically 10 power 5 microseconds. Okay, 100 milliseconds we have to convert into seconds. Finally we have to multiply with 10 power 6. Then this value will be 10 power minus 1. Finally 10 power minus 5 will come. Okay, so how it is? Here this is the microsecond, 10 power minus 1 into, so we want to convert into this value means opposite value we will give. So what is the value? 10 power 5 will come. 10 power 5 microseconds. Okay, the period of signal is 100 milliseconds. And what is the frequency of kilohertz? So they are given period is 100 milliseconds. First, what they did? 100 milliseconds. So what is the meaning of that? 100 into 10 power minus 3 seconds. What is the value now? 10 power minus 1 seconds. We have converted this value into seconds. Then they are asking into frequency in kilohertz. What is the frequency? So now you can say frequency equal to 1 by time, because it is inverse of the period. So 1 by 10 power minus 1. So the value is 10. So finally 10 into how many kilohertz they are asking. So kilohertz means 10 power minus 3 kilohertz. Okay. So now what will be happen? 10 power minus 2 kilohertz. This is the answer. So how we can write it? 0.01 kilohertz. So now we are going to discuss about frequency. Already we know that frequency is number of periods in per seconds. Frequency is the rate of change with respect to the time. Change in a short span of time means high frequency. What is high frequency? In short span. So it will take fastly. So this is the high frequency. Okay. So next one. It is taking long span of time means low frequency. What is the low frequency? Taking so long span. Okay, so this span is there, no? This is long period. If you take that is called like low frequency. If the signal does not change at all, the frequency is zero. So frequency is not changing means so it is not up and down. So it is simply going on. That means frequency equal to zero. Okay. So if signal changes instantaneously, so that means it is going like that. Some continuously it will change the values. That is infinity. So dear students, now I am stopping my video presentation here and we will continue this lecture in next video, SLT 5.2. Please watch SLT 5.2 for continuing.